My daughter proudly works as a barista at Dutch Bros Coffee in Scottsdale, Arizona. Let's imagine for a moment that she was a manager and it was her job to think about things like staffing decisions, inventory decisions, when cleanup should happen, that type of thing. I am going to just kind of enter in, and I have no reason to expect this is the case, but let's imagine that within a particular hour on an evening shift on a weekday, the Dutch Bros location might expect to have 12.6 customers per hour. That 12.6 long run average would be our lambda value. And the way that we would work through this chart or table or graph is column by column. So this first column is, well, what if there were 0 customers or 1 customer or 2 customers that come through the drive-through 50 minutes over the next hour? And the PMF column tells you the associated probabilities given your lambda. So if you expect to have 12.6 customers per hour, well, then the probability that you'll have exactly 8 would be 0.0531 or 5.31%. The CMF column, as it always does, tallies up all of the PMF values up to your value of interest. So for instance, once again, with 8 customers, there is an 11.95% chance that you will see 8 or fewer customers over the course of the next hour. These columns over here, just to let you know, have to do with like a long way of doing the expected value and the variance. But we do happen to know that for a Poisson distribution, the expectation of the distribution, the expected value, is the lambda, as is the variance. The variance is also equal to the lambda. Now, just as a quick reminder, very often we think more about standard deviation than variance, so you have to take the square root, as you always do. And so, for instance, here, the square root of 12.6 is 3.55. So we would have a long-run mean of 12.6 and a standard deviation of 3.55. These columns here are just sort of doing that same thing, but taking the long way. And the visuals that I have for you are just a visualization of the PMF here. So for instance, we have like for 9 guests, we have a 7.44% chance, or for 16 guests, we have a 6.50% chance. Down here, we see the same. We have the PMF in columns in peach, and we have the associated CMF. So we can see how the probability, the cumulative probability, is building as our random variable, as our count grows. The last thing I want to turn your attention to, and this is going to be helpful in the exercises for you in the next path, is these values here. We have the PMF at x equals a and the CMF at x equals a. And these are your standard statistics textbook problems. Someone says, well, what is the probability given a long run average of 12.6? What is the probability that you would see exactly 23 customers? Well, you can go right here and it would be 0.00265. It would be the probability of seeing exactly 23 customers. And for the CMF value of seeing 23 or fewer customers, it would be 99.728. If you wanted to change this over and make it 11, well, there's a 10.7% chance of seeing exactly 11 customers and a 39.5% chance that you would see 11 or fewer customers. That's really all you have to do. You can answer a lot of questions by doing that. Just so you know, what I did here is I put equals Poisson.dist. I put my value A of interest. So in this case, it's I7. And then I reference the lambda from here. Now for a PMF, you put in false, comma false. And for a CMF, it's all the same stuff, Poisson, and then you put in true. So that's what's going on under the hood, so to speak.